Okay, exercise 8.3, problem 15, discussion. Let's read the problem. A container with a rectangular base of length 4.4 meters and breadth 2 meters is used to collect rainwater. The height of the water level in the container is 4 cm and the water is transferred into a cylindrical vessel with radius 40 cm. What will be the height of the water level in the cylinder? Okay. So basically what they're saying is that they have a rectangular tank, basically container or a tank. Okay, the length and the breadth is 4.4 meters and 2 meters and the water in that is 4 centimeter. This is going to get transferred to another cylinder whose radius is 40 centimeter, and we are asked to find the height of the water level in the cylinder after filling. So what is it? Very simple. Whatever volume of water is in the tank is the one which is going to get transferred. So all you need to do is that equate the volume of the water in the tank to the volume of the water in the cylinder. Then you should be able to calculate the height of the water. Okay. Right. So let's mark what is given here. The length of the tank or the container is 4.4 meters, breadth is 2 meters, and the depth or the height is 4 centimeter. Then for the cylindrical vessel, the radius is 40 centimeter. I guess that's all is given. So you can see the length of the container is 4.4 meters, which is 440 centimeters. You got to be careful because the depth isn't given in centimeters, so we need to convert everything to centimeters. Okay, and the cylindrical vessel is also given in centimeter, so we are converting everything to centimeters. Breadth of the container is 2 meters, that is 2000 centimeter. Height of the water level in the container is 4 centimeter. Radius of the cylinder is 40 centimeter. Okay, I guess we have finished that. Now what are we asked to calculate? We are asked to calculate height of the water, okay, in the cylinder. We are asked to calculate the height of the water level in the cylinder. As I told you earlier, whatever water is in the rectangular tank is going to get transferred, so volumes will be equal. So let's list the formula. Volume of the container, which is a cuboid. Okay, the container is a cuboid and the volume of a cuboid is length into breadth into height. The volume of the cylinder we know pi r squared h. Okay, in this case r is known, h is not known. Here length, breadth and height are known. So the key point or the hint is the volume of the water in the container is the same volume of water in the cylinder. Both the volumes are same because this is getting transferred to this. So whatever volume of water is in this container will get transferred here. Okay, it's the same quantity, I mean to say. So volume in the container and the volume of the cylinder will be same. So LBH will be equal to pi r squared h. So here everything is known except height, only one unknown. We should be able to calculate it. Okay, it's quite simple. So let me summarize it for you. Let h be the height of water level in the cylinder. Equate the volume of water in the container to the volume of water in cylinder. Okay, the same quantity. Okay, that's what it means. To get LBH equal to pi r squared h. Okay, so from this equation we should be able to calculate h. Substitute the values of length of the container, breadth of the container, height of water in the container, and r, the radius of the cylinder, in this formula, and calculate height, which is the height of the water level in cylinder. Okay, so I guess that is it. So please pause the video here and try to do the problem on your own. After doing, come back and look at the solution. So now we are coming to the solution. The length of the container is 4.4 meters, as I told you earlier. That is converted to 440 centimeter. Breadth of the container is 2 meters. That is converted to 200 centimeter. Height of the water level in container is 4 centimeters. The radius of the cylinder is given as 40 centimeter. Let h be the height of water level in cylinder. Quantity of water in the container is the same quantity in cylinder. Both the volumes are equal. So when you equated, volume of the container, which is a cuboid, is LBH. Volume of a cylinder is pi r squared h. So equating it, we get LBH equal to pi r square h. Now substitute the values of L, B, H and R in 1. We will get L is length is 440 into breadth is 200 into height of water is 4 centimeter will be equal to 22 by 7. The radius is 40 for the cylinder, so 40 into 40, and H is unknown, we have to calculate here. So H will be equal to, okay, so to all these things, 440 into 200 into 4 into 7 divided by 40 into 40 into 22. So you can see 22 will go 20 times, okay, and 20 will go 2 times here, 2 will go 2 times here, and 40 will go 5 times. So 5 2s are 10, 10 into 7 is 70. So if you simplify this fraction, you will be able to get the height as 70 centimeters. You got it? It's very simple. It looks complicated, but the moment you have this key concept, that quantity or the volume before transfer and after transfer are the same, or the volume of the water in the container will be the same when it comes to volume of the water in the cylinder, because you are transferring the entire amount. Okay, once this is known, everything else is easy. Then it's basically substitution and simplifying. I hope you got the problem correct. If not, please check where you have gone wrong and make the correction. Okay. If you have not understood the concept, please go back to the discussion part of the video and try to get your concept clear. Okay. Thank you for watching.